In this video, we'll discuss population variance and standard deviation. Data variation is based on the difference between a data value and the mean of the data set. This difference is called a deviation. In the outdoor paint example, the mean time before the paint started to fade was mu equals 35 months for type A paint. For a specific can, the can that lasted 50 months, the deviation is x minus m, which is equal to 50 minus 35, which is 15 months. The sum of the deviations for all data values in a set is 0. This isn't very helpful. To get more helpful statistics, we sum the squares of the deviations and find the mean of the squares. This measure is called the population variance, symbolized sigma squared. Since sigma squared is in square units and the data are in regular units, we take the square root of the variance and call it the standard deviation. So formally, the population variance is the average of the squares of the distance for each value, the distance each value is from the mean. The formula for population variance is sigma squared equals the sum of x minus mu quantity squared over n, where x is the individual value, mu is the population mean, and n is the population size. The population standard deviation is the square root of the variance. The formula for population standard deviation is sigma equals the square root of the sum of x minus mu quantity squared all over n. So here is a procedure for finding population variance and standard deviation. First, find the mean of the data. Mu equals the sum of x over n. Then find the deviation for each data value, which is just x minus mu. Square each deviation, x minus mu squared. Find the sum of the squares, sum of x minus mu squared. And divide that by n to get the variance. Sigma squared equals the sum of x minus mu squared over n. Then take the square root of the variance to get the standard deviation. Sigma is equal to the square root of the sum of x minus mu squared all over n. So as an example, we'll compare the paint, the type A paint. We'll look at the type A paint and find its variance and standard deviation. So we found the mean already. That's just mu equals 35. And then we find the deviations. We just subtract the mean from each element. So for 10, that's negative 25. For 60, it's 25. And then we've got 15, negative 5, 5, and negative 15. And note, if we added these all together, we get 0. Now we square the deviations. That gives us 625, 625, 225, 25, 25, 225. And we find the sum of the squares, which is 1750, and divide that by n to find the variance. So sigma squared is equal to 1750 over 6, which is about 291.7. That's our variance. Finally, we take the square root to get the standard deviation. Sigma is the square root of 291.7, which is approximately 17.1. We'll repeat this for type B paint. Again, we already have the mean. It's 35. The deviations are 0, 10, negative 5, 0, 5, and negative 10. We square the deviations to get 0, 100, 25, 0, 25, 100. We find the sum of the squares, which is 250, and find the variance by dividing 250 by 6, which is 41.7 approximately. We find the standard deviation by taking the square root of 41.7, which is about 6.5. The variance and standard deviation for type B paint are much smaller than those for type A. When the means are equal, the larger the variance or standard deviation are, the more variable the data are.